Hello, this is Nikki Jackson from Southwest Tennessee Community College going over a few examples from Math 1710, Self-Check 2.1. So hopefully you can see what has been written out right here. So one of the first examples that's provided to you is the polynomial equation of x cubed plus 2x squared minus 5x minus 6 equals 0. Given that 2 is 0. It wants to find the other rational zeros, so what we're going to do first is use synthetic division. So when you do the synthetic division, you're going to be using coefficients. So you probably can't see that. That's kind of light right there. But you're using the coefficients of 1, 2, -5, and -6. So that these numbers represent right here. And the 2 was a given 0. So following the steps of synthetic division, bring down that 1, and 2 times 1 is 2. 2 plus 2 is 4. 2 times 4 is 8. -5 plus 8 is 3. And 2 times 3 is 6. So -6 plus 6, you have a remainder of 0. So now you're going to rewrite this as a polynomial. So once again, these represents the coefficient. So now you have x squared plus 4x plus 3. Now this particular polynomial can be factored. So factoring, looking at that very last term, which is 3, we know that 3 only has factors of 1 and 3. Hence, that's where the 1 and the 3 come from. Notice how you have 2 plus signs right here. Therefore, your signs are also going to be positive. But now we have to let each one of those binomials equal 0. So I have x plus 1 equals 0. So once we solve for x, that's -1. Then x plus 3 equals 0. Once you solve for x, you got x equals 3. Therefore, your solution set for your zeros is 2, -1, and -3. You see where the -1 and -3 come from, but remember, the 2 was a given. We're going to do another example of synthetic division using the remainder theorem. So for this one, we have a polynomial of 4x cubed minus 11x plus 8x minus 7, where f of 1 is given as a 0. So notice right here, we're using synthetic division. Your coefficients are 4, -11, 8, and 7. So let's see how we get the remainder of -6. So you bring down your first coefficient, and now we're going to use division. 1 times 4 is 4, so -11 plus 4 gives you -7. 1 times 7 is -7, so 8 plus -7 is 1. And 1 times 1 is 1. -7 plus 1 is -6. So notice that this very last column is going to be your remainder. Other examples of zeros in the polynomials are in the form of a graph. So here's a problem in its entirety. So hopefully you can understand some of my little scribble scrabble, which I call very bad penmanship. Given to you, you have 2 times x minus 5 times x plus 9 squared. That's your actual polynomial. It wants to determine the multiplicities of the zeros, but first, identify what the zeros are. So let's identify what the zeros are. So here goes the actual polynomial without the 2. So I'm going to separate each one of those binomials. Or factors is a better way of saying it. So once I factor it out, I have x minus 5. Notice how the 5 does not have a power that's written. So we're going to assume that that's just the exponent of 1. Therefore, it has a multiplicity of 1, and 1 is an odd number. Thus, the graph will cross an axis. And the 0 is going to be positive 5. Then when you look at the x plus 9 squared, it has a multiplicity of 2. Notice how I'm looking at the power. And the 2 is an even number. Thus, the graph will touch the point and then turn around on the axis. The other 0 is going to be -9. So far we have our 2 zeros, which would be 5 and -9. The multiplicity of the larger 0 is going to be 1, because the 5 is bigger than your -9. And the multiplicity of your smaller 0 is going to be 2, because your 0 was -9. So again, the multiplicities are based upon your exponents. But now we have to figure out where they're going to cross. Well, Once again, it's dealing with your multiplicity. Since 1 is an odd number, it will cross the axis. And since 2 is an even number, it's going to touch that point and turn around. So in case you don't remember what some of that was, it'll be a good idea to make sure that you write some of your notes down. And this is provided for you. Some more detailed notes about when it touches and crosses is going to be provided for you into stcc.mylabs Plus. Here's another one that's dealing with the touch and cross. And again, my little scribble. So for this particular one, you have a graph that's already provided for you. Pay close attention to the x-axis. So if this is going to be 0, that means that's 1, 2, negative 3. And this one is 1, 2, 3, 4, 5. Pay close attention to what it is. It says list the zeros whose multiplicity is even. Well, remember, if it's even multiplicity, it's going to touch and turn around. So notice how it's touching right here and then bounce back up at the negative 5. Then it says list whose multiplicity is odd. Well, notice how it crosses the x-axis right here at negative 3. Now we have to figure out how to do an equation for this. It says write an equation using the leading coefficient of 1 and negative 1. Well, we know it's not going to be negative 1 because notice how it's going upward on the first time around and not downward. So given that we already know that this is going to have an even power, this one has an odd power, this is what we come up with. We got x plus 1 to the first power, then x minus 5 to the second power. These are coming strictly based upon where the graph touches or crosses the x-axis. Hence why we have this. But now it wants to know what the y-intercept is. Well, let's work it out. Given we have an equation where your leading coefficient is 1, we have to work this out using the form method along with the distributive property. Right here, we use an expanded form using the form property. And now we're going to use distributive property. So pay close attention what I mean by distributive, that you have to multiply each term on the outside of parentheses by each term on the inside. You may need to pause the video to see exactly what I mean by this. Now to find the y-intercept, we're going to let x equal 0. Therefore, once you submitted 0 as x, your final answer, which leaves you as the y-intercept, is going to be positive 75. With this particular example, we had a leading coefficient of positive 1. But let's see about this one. And again, my apologies for my horrible handwriting, but hopefully you can decipher it. So given the polynomial function, we have 6x to the 7 power, my apologies, plus 8x cubed plus 4x squared plus 3. Your leading coefficient is always going to be depending on your largest exponent. Therefore, your largest exponent is 7. Just so happens 7 is an odd number and it's positive. Since it's odd and positive, it's going to fall to the left and rise to the right. Those notes, once again, are more in detail in your stcc.mylabs Plus. But with my poor penmanship, and hopefully you'll be able to get it, let's figure out what's that in summary. So when your leading coefficient is odd and is positive, your graph is going to fall to the left and rise to the right. If your leading coefficient is still odd but yet negative, it rises to the left and falls to the right. If your leading coefficient is even and positive, it rises to the left and rises to the right. If your leading coefficient is even but is still positive, or it is positive, it falls to the left and falls to the right. Again, my apologies for my little scribble, but more detailed notes are provided in stcc.mylabs Plus. Now going back to synthetic division. FYI, you may notice that these are examples coming directly from your self-check. Ooh, I'm tongue-tied. So for this particular example, it wants you to use synthetic division to simplify the equation. So let's do so. So here we go. We know that we're using synthetic division. So we're going to have 1. And your coefficients are 9, 1, and negative 10. Bring down your 9. And now let's do the simplification. 1 times 9 is 9. So 1 plus 9 is 10. 1 times 10 is positive 10. Combine it. You have no remainder. Let's rewrite this in the form of this. Because all of your powers, aka exponents, will be in descending order, you started off with 2 exponents. So therefore, this right here would be 1 exponent, then 0 exponents. And what I'm referring to are your exponents are your number of variables. So once again, you had 2 x's right here. Therefore, your final answer is going to have 1x and then 0 x's. So 9x plus 10 is the final answer. Here's another example, looking at number 7. Make sure you pay close details with this because it might be similar or very, very similar to what you're doing yourself for your self-check. Be mindful that you have to do the homework first for 2.1. Now the answer is already D, but let's figure out where in the world that they got these numbers from. So when it's your turn, pay very close attention to these inequalities. So you have greater than and less than, greater than and greater than, less than and less than, then less than, greater than. So now I'm about to show you where they got the negative 5 and 415. Notice that they gave you intervals as well, 1 and 6. So for the first example, we're going to let x be 1, therefore f of 1. Wherever I saw x in that initial equation, I substituted with 1. Once I simplify everything, I have a final answer of negative 5. For your upper interval, it let x equal 6, so therefore we have f of 6. Wherever you saw x in the initial equation, substitute 6. So once we simplify everything, we have 415. In our last example for self-check 2.1, wants to determine whether the function is a polynomial function. Well, here goes your function right here. Notice how your exponents are in descending order. So you got your largest and then your smallest. Largest and your smallest. Sometimes I get tongue-tied, so I might say ascending, but I went from largest to smallest is what I mean. Notice how your largest exponent here is 6. Therefore, it has a degree of 6. The reason why it is a polynomial is because, well, that's because you can actually identify what that larger exponent is. So ladies, gentlemen, individuals, thank you for tuning in. This is the last example for Self-Check 2.1. I look forward to working with you again for Self-Check 2.2.